All right, good morning, guys. We're on a new chapter. We're going to be doing chapter 8, which is going to be all about the atmosphere. So go ahead and open up the first set of notes that I gave you. You guys can obviously hit pause at any point. So if I tell you guys, oh, do this, do that, write this down, just hit pause and then keep watching the rest of the video. All right? And please, if you see somebody next to you not watching the video, encourage them to do that. That's going to help all of us tomorrow to be able to pick up where we're ending with today's notes. All right, great. Let's get going. So, how do clouds and mist form? Clouds and mist, as we have discussed, and fog, which by the way is cloud at Earth's surface, is the result of condensation or the phase change of gas into a liquid. So remember, condensation is gas into liquid, which means, we've said this before, all clouds are liquid or solid. Remember, with the solid part, they could actually be ice crystals. All right. So let's get into some of this. But first, let's try and understand, very simply, where in the atmosphere do clouds form? So clouds, water, and really all these things that we call weather take place in a layer of the atmosphere called the troposphere. The troposphere is the layer closest to the Earth that we interact with. So if you think you're chilling down here on Earth, right, everything's going to be blue right now, I apologize, right, all the air and gases that are all around us right now, you're in the troposphere. We would have to go way up, and that's when we would leave the troposphere and go into another layer. It's also the perfect place for us to have some clouds. And I said we can have clouds at or near Earth's surface. That's what we call fog. Alright, so if you walked out your house this morning and it was foggy, well then you've actually walked through clouds. I don't know. I think that kind of stuff is cool. Let's keep going. Quick note on the vocab. Right, these are all terms that we're going to be defining for homework. So just stay tuned. And speaking of vocab, atmosphere is actually a review term. We discussed this in the first chapter when we talked about Earth's 4/5 spheres. So it's the envelope of gas that surround the Earth. Nice, easy definition. Well, when you say the envelope of gas, well, what gases? And it turns out that nitrogen and oxygen are the two most abundant gases in Earth's atmosphere. So, we got nitrogen over here coming in at approximately 78%, and then we have oxygen at 21%. And for all the mathematicians in the room, you're like, wait, so that means that 99% of all of Earth's gases are nitrogen, oxygen? Everything else you can think of makes up that 1%. And by the way, just in case you're wondering, the third most abundant is argon. And then think about some other gases. Maybe you've heard of this thing called H2O. That's right, some water. CO2. And let's not forget about cow burps, right? So we got some methane, right? Flammable, by the way. So just throwing some gases out there for you guys to start to think about. Obviously, there are many more that we can go on with. But if I can use the word ideal, if you just gave a parcel of air from anywhere in the atmosphere, consistently, we would find a 78%, 21% concentration. And then over here, you're seeing the amount of carbon dioxide and the amount of argon, all of that breaking out. now there's some important things to understand. The concentration of atmospheric gases can vary over time. And we're talking like Earth history time, right? Or are we? Because, I mean, carbon dioxide is known at this point. We generally accept the idea that the carbon dioxide levels have been increasing due to the burning of fossil fuels. Okay, if this is upsetting any of you, it's reality. And we can either ignore it or we can try to understand really what's going on. I like the second option. All right, let's understand what's going on. Right, if we go back 150 years ago, we were at about 278 ppm, parts per million. And 150, 200 years later, we're actually right now at about 413 ppm, which means not only have we increased by 100, we've actually exceeded that. And we're going to continue to increase the amount of carbon dioxide in the atmosphere because we continue to put more and more cars on the road, we continue to build more and more houses, we continue to burn more. And that's a reality that some people don't want to accept, but there's a consequence to that. And we're going to see in a few minutes that CO2 is a variable greenhouse gas. It's a variable greenhouse gas, which means the concentration has increased and decreased. But greenhouse gases work like a blanket in the atmosphere to trap outgoing long-wave radiation. And right now you're like, you are using a whole bunch of words I don't understand. You're going to have to draw me a picture. And we will. I'll get into this tomorrow in much more detail. But for right now, just understand that the amount of carbon dioxide and other gases can vary, and there's a direct correlation between the rising temperatures that we're seeing, melting ice, stuff like that, and the concentration of CO2. All right, we're going to stop on that one and move on to the next topic, which happens to be ozone. Now, ozone is an O3 molecule. O3 molecule, right? We breathe in O2, right? And that makes us happy. But ozone in the stratosphere, which is going to be the layer of the atmosphere above us, makes us happy down here, right? Because we want the UV radiation to be absorbed, as you're seeing in this diagram, right? It's going to stop it from making it all the way down to Earth. We do technically have O3 at Earth's surface, but we call that bad ozone. You don't want to go breathing in ozone, okay? Because our body wants O2, not O3. Again, I can expound on that tomorrow. All right. So, variable atmospheric gases. All right, I'll explain this graphic a little bit more tomorrow, but basically that's showing you where the ozone layer is. So when we talk about height above, this really is trying to show you the layers of the atmosphere and the fact that the stratosphere is where you're going to have that ozone layer, that real high buildup, right? So this center section right in here is where that ozone layer is going to be. And again, that stratosphere. I'll keep saying stratosphere over and over again. Hopefully it starts to become ingrained in your memory. All right, so we got through ozone. We understand a little bit about the nitrogen, oxygen, carbon dioxide. There are some other things, though, out there, right? There's some tiny particles, dust, salt, ice. When we think about dust, soot, pollen, all of these can actually be what we call condensation nuclei, which are going to be important for forming water droplets. Right? Condensation nuclei. And And basically, if I have a little chunk of dust, right, little looking dust thing, then I can actually have water molecules come along and they attach and they start to grow larger and larger. Without having that little core, it doesn't have anything to attach to. And we'll talk more about that when we do weather. But yeah, condensation nuclei, these little particulates that are floating around, sometimes are important. Alright, so I said today we were going to do the layers of the atmosphere, and there you have it. You got the troposphere, stratosphere, thermosphere, exosphere. And we'll basically see each one of these listed out. You want to practice, when you're studying tonight, you want to practice drawing the Earth and the different layers of the atmosphere. Right? So if each time you think about this, you go, okay, Earth, and obviously you guys can write them all out, and then give yourself like the different layers and go, okay, troposphere, that's where I'm going to have all the weather. Right? Then I'm going to have stratosphere, that's where we find the ozone. And then I'm going to find the mesosphere, and that's where we're going to get meteor showers. And then the thermosphere, technically that's where I have the ionosphere, where I'll see auroras and all that. It's going to be the hottest layer of the atmosphere. And then the exosphere out here, and that's where we'll have our transition over to space. Alright, so that's actually where we can have a lot of satellites orbiting. Now, if you go through stuff like that, please write everything out. I'm doing it quickly for the purpose of this lesson. I don't want you to be sitting there for 10 minutes watching me write each word. But you guys get in that routine of writing each thing out, draw those pictures, make those connections, and these ideas will go from just being words on a page to actually being a picture in your mind. Alright. So now I'm pulling out my highlighter because for me it's some highlighting time. But you guys have a little bit more writing to do. Alright, so the troposphere, again, closest layer to the Earth's surface. Most of the mass of the atmosphere and where weather occurs. If you understand that, you're off to a good start. Now, why did I say that most mass of the atmosphere? Well, because gravity is a thing. It's that force that's pulling down on the particles in the atmosphere. So the heavier molecules are all going to get pulled down under the force of gravity and held real close to Earth's surface. So like 90%, over 90% of everything in the atmosphere is really in the troposphere. Right? The layers get thinner and thinner as you go up. Thinner in composition, not in a vertical thickness. I gotta be careful how I say that. Alright, and as you go up into the troposphere, the temperature will decrease with altitude. Now, this for me always seemed obvious, and there's a good reason why. See, I like to do this thing called skiing, and skiing you do at the top of a mountain. Where it's what? Cold. Right? If any of you have done any skiing, if you're doing any skiing maybe this weekend coming up, great weekend to do some skiing. When you park your car down here, right, and you're like, okay, cool, I'm going to go hike up the mountain, the temperature is going to drastically decrease as you go up. And that's because you're moving away from Earth's surface. So if that alone helps you to remember, right, temperature will decrease with increasing altitude. Alright, now that is, again, just for the troposphere. Now there's a boundary between the troposphere and the stratosphere, and that is actually what is called the tropopause. And the reason we call it tropopause is now the temperature is going to pause, and then it's going to start going back in the other direction. So key points here that I want to go and highlight. Got my highlighter out, right? Temperature is going to increase with altitude, and you're going to have the ozone layer. So now, why would temperature start to increase? Well, that absorption of ultraviolet radiation that I was talking about before by the ozone, and when it absorbs that radiation, the molecules vibrate and they release heat. So the temperature is increasing because of the ozone, because the ozone's absorbing radiation. All right, I think that's pretty clear. We'll review this. Then we hit the mesosphere. So again, you're climbing all the way up. You hit the top of the stratosphere, and again, at the top of the stratosphere, you'd have the stratopause, and then you go into the mesosphere. So the mesosphere now is going to actually change. Temperature is going to drop. And so the decrease in temperature is going to increase with altitude. And it's actually going to be the coldest layer. So let's put some fun notes under here. Coldest layer. And meteors burn up, aka meteor showers occur, right? And that's when you have like the little bowl of burning hot rock that's coming in, and we see them as shooting stars. Cool. So meteors burn up in the mesosphere, and the mesosphere is the coldest layer. That's pretty much all the fame and excitement you get in the mesosphere. And then we hit the thermosphere. Now this is going to be the higher layer, right? So again, we're going to be above the mesopause, and then you're going to have the highest temperatures, and that's because you have the radiation that's coming in, right? So that high level radiation, the X-ray, the gamma rays that are going to be intercepting with Earth's magnetic field, and the ions of the ionosphere. All right, we'll break that down a little bit more tomorrow. Then we said the exosphere. The exosphere is that transition where you're leaving the Earth's atmosphere and you're entering out into space. So this is where they're placing those satellites that make your cell phones work. So we have the space junk that they've got to figure out what they're going to do with the old broken down satellites, the ISS, all that types of good stuff. All right. Again, I think some of this, once you write it down, becomes a lot easier to understand. There is a little chart that I embedded in your notes so you guys can make note and kind of check off, okay, yeah, I understand what's happening there. And then this would be a perfect diagram to put onto a test, right? Do you understand? All the way down here, you can see at the bottom, you got clouds. Down the troposphere, you get mountains, you got temperatures decreasing. There's that little mountain top that I was talking about skiing on. Then you get into the stratosphere, you have the ozone layer, temperature's going to increase. Then mesopause, temperature's decreasing. Then we come up, you can see the meteor coming down, and then it's going to go streaking through the mesopause. It's a little crookedy crook. There we go. You can see the vastness of the thermosphere, and then all the way up there in the exosphere we have our satellites. Cool. So I think it's actually a good point to stop. I can pick up with this tomorrow. So use the rest of your time to start your homework, which is going to be that vocab sheet that I put in Schoology. All right? Have a great day, guys. Thank you.